If you want to bake a cake, you should probably follow a recipe. It tells the amount of ingredients that you need to use and the number of cakes you can form from those ingredients. Quantifying reactions is much the same. The balanced equation is our recipe, and it tells us how much product can be formed from a given amount of reactant on a mole basis. We will develop a straightforward way to quantify reactions. Balanced equations give the mole ratios of reactant to product for reactions. We can use a balanced equation as a recipe. If we know how much reactant we have to start with, we can predict how much product will form during the reaction if the reaction goes 100% to completion. Let's use the decomposition of sulfur trioxide to form sulfur dioxide and dioxygen as an example. If we know how many moles of SO3 we start with, we can determine how many moles of SO2 and O2 can form. The coefficients in the balanced equation are the key. The balanced equation tells us that 2 moles of SO3 react to form 2 moles of SO2 and 1 mole of O2. Notice this 2 to 2 to 1 ratio comes from the balanced equation. This ratio holds regardless of how much we start with. For example, if we start with 6 moles of SO3, we should form the same number of moles of SO2 and half as much O2. It will always be a 2 to 2 to 1 ratio. We could solve this problem using the conversion factor approach. Again, if we start with 6 moles of SO3, how much SO2 and O2 can we form? The conversion factors come from the balanced equation. If we are interested in forming SO2, the stoichiometric factor comes from the coefficients in front of SO3 and SO2. As always in these types of calculations, we start with the number given, 6 moles of SO3, and apply the conversion factor, taking care to put moles of SO3 in the denominator. Calculation yields 6 moles of SO2. If we're interested in forming O2, we look at the coefficients in front of SO3 and O2. This would be a 1 to 2 ratio. Starting with 6 moles of SO3 and applying the conversion factor, we form 3 moles of O2. Let's put together the steps to solve this type of problem. If we're asked how many moles of O2 can be formed when 1.78 moles of SO3 decompose to SO2 and O2, the first thing we would need is a balanced equation. We've seen this one before, but if this were a new problem, we would need to balance it. Then we would look for the coefficients of the 2 chemicals of interest, in this case SO3 and O2. Then we would set up the calculation, starting with the number we're given in the problem and constructing a conversion factor with the coefficients. Calculation gives 0.89 moles of O2. In summary, we have used the balanced equation as a recipe to predict how much product can form, given a known amount of reactant. For more complicated problems, we can construct conversion factors from the coefficients in the balanced equation.